What's going on, guys? In today's video we'll be talking about parallel and perpendicular lines. Before we look into any of the examples, let's try and understand the basics of the subtopic over here. It says given line L1 with parametric equations, these over here, and we've given L2 as well, L1 and L2 with their specific parametric equations. If L1 is parallel to L2, we can know that B1 upon B2 is going to equal to D1 upon D2, which will equal to F1 upon F2. Where are we getting these values from? We've denoted that with their parametric equations that x equals to A1 plus B1t, y equals to C1 plus D1t, and z equals to E1 plus F1t. This is for line 1. L2, same thing, x equals to A2 plus B2t, y equals to C2 plus D2t, and z equals to E2 plus F2t. So, if we want to find parallel lines, if they want to know that they're parallel, we can just do this over here to determine if they're parallel. If you want to figure out that they're perpendicular, multiply B1 B2 plus D1 D2 plus F1 F2 equals to 0. If that, in an example, gives you 0, you know that it's perpendicular, just like the dot product. Very similar to the dot product, this over here. And if you want to know if they coincident, if lines are coincident to each other, B1 upon B2 equals to D1 upon D2 equals to F1 upon F2, which then equals to A1 upon A2, C1 upon C2, and E1 upon E2. So, been developed shortcuts in order to help us with this topic over here. Relatively straightforward once you get the understanding and get it in your head. So yeah, we'll go into the first example now. Looking at this first example over here, we've been given two lines written in their parametric equation forms. Find A if these two lines are parallel, and B if these lines are perpendicular. To do A over here, we developed earlier in the video, knowing that if two lines are parallel, then we know that B1 upon B2 equals to D1 upon D2, which equals to F1 upon F2. Correct? In this case, B1 is 2 upon 2 equals to 1 upon 2, which equals to negative 2 upon 2. But we know this and this do not equal each other. Therefore, L1 is not parallel to L2. Correct? Very simple, straightforward method to determine if they're parallel or not. And then B, over here, we're going to take the dot product of the directional vectors of L1 and L2 in this case. And in that case would be, for L1, the directional vector for L1 is going to be 2, 1, negative 2. And for L2, it'll be 2, 2, 2. 2, 2, negative 2. We know that it's perpendicular when the dot product equals to 0. So take the dot product of this. We get 2 times 2 is 4, plus 2 is 6. Sorry, plus 2. So 4 plus 2 is 6 times negative 2 times negative 2 is 4 plus 4. 6, 4, 10. Therefore, not perpendicular because the dot product does not equal 0. So that is how you do Example 1, relatively straightforward once we understand the formula derivation, these questions become very easy. So now on to the next example.